Hey everyone! Official firmware for Flipper Zero recently implemented new JavaScript features for GPIO and UI in their dev branch. The biggest change is a new eventLoop module. A bunch of functions also got renamed. If you're running existing scripts on your Flipper Zero, they'll likely need to be updated. In this video, we'll talk about many of the new JavaScript features. Let's get started. We'll begin with a demo I wrote. So go to SD card, apps, scripts, and then drag the JavaScript into that folder. Then on your Flipper, we'll load up apps, go down to scripts, and then choose a_demo.js. It prints run event loop. And then 2 seconds later, it says hi after 2000 milliseconds, done with event loop. So let's take a look at the code. We imported the event_loop module using require event loop, and we set that to our event loop variable. Next, we created a timer contract, and that timer will go off one time after 2000 milliseconds. We created a function called hiMessage that takes two parameters, subscription and item. In this simple example, we're not using either of these parameters. This function prints the message hi after 2000 ms, and then it calls eventLoop.stop, and eventLoop.stop will cause any eventLoop.runs to exit, as we'll see in a moment. Next, we called eventLoop.subscribe, passing it our timer contract and our hiMessage function. EventLoop.subscribe requires that this function's first two parameters are subscription and item. We print the message run event loop, and then we called EventLoop.run. All of the subscribed contracts start getting evaluated. After 2000 milliseconds, our timer contract fires, and the event loop run will call the associated hiMessage function, passing it a subscription and an item. This prints the text hi after 2000 milliseconds, and then it calls eventLoop.stop, which causes our run method to exit. And then we print done with event loop. Next, let's refactor the code so it looks more like the examples. We'll start by getting rid of the timer contract variable. So we'll copy the code for timer contract, and then we'll delete the timer contract line. For unused parameters, we'll prefix the name with underscore so we know we're not using those parameters. Next, we'll move the hiMessage function directly into our subscribe call. So we'll remove the name hiMessage from our function. Then we'll copy the function to our clipboard and replace hiMessage with the clipboard. And then finally, we'll move the close paren to the same line. Currently, our function is using the global variable event loop, so we'll modify the function to take an extra parameter of event loop instead. In our subscribe call, we'll now add an additional parameter of event loop. When event loop run calls our function, it will pass us the subscription and item along with that event loop that we've specified. With those changes made, we'll drag our new JavaScript file, and then we'll go into a_demo.js, and there's run event loop, and 2 seconds later, hi after 2000 ms, done with event loop. The JavaScript libraries now have Intellisense, so if we hover over timer, we can see that first parameter should be either one-shot or periodic, and that second parameter is the interval in milliseconds. On developer.flipper.net website, we can open JavaScript, and then open JS event loop, and then API reference, and there's all the methods. I'll click on timer, and there's the documentation for the timer API. So we'll change our timer to periodic, and then we'll change our interval to 1 time a second, so 1000 milliseconds. We'll update our function to have a counter parameter, and then we'll change our print function to also print the counter's value. Next, we'll only call stop when the counter exceeds some value. Sure, we'll use if counter == 5. And then we'll return the parameters to use the next time our event happens. So the next time we get called, we want that counter to be one more than the previous time. And if you don't have a return statement, you'll get the same value as before. And then finally, we have to set our initial values. I'll use a count of 1 as our initial value. So a quick review, your function takes a subscription and an item, and then it can take as many additional parameters as you need. It returns an array with those additional parameters specified for the next time it gets invoked. And we list out the initial values in our subscribe function. We'll copy our updated script to our flipper, and then we'll go ahead and rerun the demo. There's our run event loop, and then our counter message 1, 2, 3, 4, and 5, and then done with event loop. So now we understand how event loop subscribe works and the event loop timer. Let's take a look at GPIO. We'll start by running the GPIO example script. And you can see the light toggling its state 1 time a second. And when I press the button, you can see we're reading the value of the potentiometer. The switch isn't a perfect signal, so we do get a few different values read when we press the button 1 time. The first thing we do is require that event_loop module, and then we require GPIO. The order of these calls are important. If you try to require GPIO without requiring the event loop first, you'll get a GPIO module load fail when you run your script. This is the first time we've had GPIO support in official firmware. The API works a little bit differently than we've had in some of the custom firmwares. You can see here we're doing a GPIO get for PC3. So that's pin C3 on your flipper, or you could have used the numeric value of 7. Printed on the left side of the flipper. Next, we do GPIO.get for PC0, and pin C0 is connected to our potentiometer's output. We have a button connected to pin C1, and so we do GPIO.get PC1. On our LED variable, we call .init. The direction can be in or out. We use out because it's an LED that we're outputting voltage to. And because the direction is out, we use the property out mode with a value of push_pull. This means the value will be pushed to ground or pulled up to 3.3 volts. The other choice is open_drain, which gives an output of either ground or an open circuit. Next, we initialize the potentiometer. This time our direction is in, and we have an in mode, which we set to analog. Analog means you'll be able to read different voltages between 0 and 2 volts. And finally, we initialize the button. The button's direction is also in. We enable an internal pull-up resistor using a pull of up. You could also use a pull of down. Or as you saw in the potentiometer example, don't specify any pull if you don't want any pull-up resistors. Our in mode is interrupt. This means we can subscribe to changes in that value. And for in mode interrupt, you're able to say the edge is falling, rising, or both that you're interested in. If you don't want interrupts and you just want to be able to read the state of a pin, you can also use plain_digital for the in mode. Now that everything's initialized, we print a message commencing blinking PC3. Then we call eventLoop.subscribe, passing it a periodic timer of 1,000 milliseconds. The first 2 parameters to our function are subscription and item, which they've named underscore and underscore item. And then we have an LED parameter and a state parameter. Our state parameter is a Boolean, true or false, and we call LED write with that state, which will turn on or off the LED pin. We return an array with our 2 additional parameters, LED, and this time not state. So if state is true, next time we get called, it'll be false. And if it's false, next time we get called, it will be true. Finally, we pass our additional 2 parameters, LED, and our initial state of true. Next, we print a message, press the button, PC1, and we do another eventLoop.subscribe, but this time we use button.interrupt, open close parenthesis. This will get triggered every time the voltage falls from 3.3 down to 0 volts. And our function takes that subscription and item, which we name underscore and underscore item. And then it also takes our pot variable. So every time our button pin goes to ground, we'll print the message PC0 is at, and then we'll use pot.readAnalog to read the analog voltage in millivolts. And then we write MV. Notice that read analog is currently snake case. I don't know if this will become camel case in the future. And then finally, we specify the pot parameter. And then we call eventLoop.run, which will evaluate our subscriptions and call that periodic timer as well as our button interrupt. With eventLoop, we're now able to call functions with both a timer and a switch. Next, let's look at a UI example. This is the old dialog example before we had eventLoop. I'll go ahead and run dialog old.js. We would call dialog.message, passing it the title and the text, and we'd get back a true if the user pressed OK, and a false if they pressed the back button. I clicked OK, so this will print true. And for custom dialogs, we would set the header, the text, and then the text for the left, right, or center button. And then we would call dialog.custom with our parameters, which would return an empty string for the back button. Otherwise, it would return the text that we associated with the button. I'll press the left button, and now we can see our print output. Again, we printed true if we said OK, or false if we clicked back. And then we printed left is pressed or back button is pressed. The old UI modules have been removed, so let's look at how to implement the same app using eventLoop. We start with the require event underscore loop, and then we do a require of GUI, which is the graphical user interface. And then we require GUI/dialog, which gives us back our dialog view. Next, we declare a views object with 3 properties: intro dialog, demo dialog, and current view. For our intro dialog, we set the property to dialogView.makeWith, and then we specify our header, the text, and the text for the center button. For our demo dialog, we set its value to dialogView.makeWith, and we set the header, text, left, right, and center values. For current view, we set its initial value to undefined. Next, we call eventLoop.subscribe, and we pass it our demo dialog.input, which is any D-pad input while the demo dialog is visible. Our function takes 2 parameters, the subscription and the item item is the label associated with the button that was pressed, so we name this variable button. When a button is pressed during the demo dialog, we'll print the name of the button is pressed, and then we call eventLoop.stop, which will cause our eventLoop.run to quit running. For this function, we probably should add a third parameter called eventLoop and pass it at the end of our subscribe. Next, we call eventLoop.subscribe, and this time we're passing our intro dialog input. Again, our function has those 2 parameters. On the intro dialog, if the button that was pressed was center, we print out the message true, and then we use GUI.viewDispatcher.switchTo, and we pass it our views.demo dialog. So this will switch our UI from that intro dialog to our demos dialog. Next, we update our current view property to views.demo dialog, and then we call subscription.cancel because we no longer need to receive input events for the intro dialog. Earlier, I forgot to mention that subscription.cancel is super helpful when you have a periodic timer that you no longer want invoked. And then I have a bug in this example. I'm passing GUI in views, which is a good thing, but I forgot to define my function as taking a GUI in views. The code still works, however, because the GUI in views are global variables. I highly recommend you add GUIs in views to your function definition. And it should look the same as this example here. Here we're subscribing to viewDispatcher.navigation, which is the event when the back button gets pressed. If the current view is on the intro dialog when we press the back button, then we print false instead of true, and then we switch to that demo dialog, and we update current view to be demo dialog. Otherwise, we must be on the demo dialog, so we print back button is pressed, and then we call eventLoop.stop to stop our run function. And then we pass our GUI and our views. As our app is starting, we call GUI.viewDispatcherSwitchTo, and we pass our views.intro dialog. This will cause our intro dialog to be displayed. Next, we set the current view to intros dialog so that our navigation callback knows which screen we're on. And then finally, we call eventLoop.run, which wires up all of our input events. I'll go ahead and update line 28. Now we're ready to test our script. We'll drag our dialog.js into our apps scripts folder. And then over on apps scripts, we'll go ahead and run dialog.js. The first time through, I'll go ahead and click OK, which will print true. And then I'll click right arrow. And we can see true and right is pressed. And then if I back up and we run it again, this time I'll click back button, which prints false, and then back button, which is back button is pressed. Thanks for watching this video. Hopefully now you understand how event loop works and how you're able to use timers, GPIO, and various GUI UI elements. I strongly encourage you to read through the GUI.js file and learn how the loading view, empty view, text input view, and submenu view can be used in your applications. Please like and subscribe, and if you have any questions, feel free to leave a comment below or reach out to me on Discord.